Teste, teste. Alô, ok. Tá, então eu queria esse Burning Timer, value change.
References have been replaced. So you can do a quick search for frying and make sure there are no frying references down here. Okay, great. Now let's continue solving all of the errors. So let's go down. For the burning timer, we need to modify the value. The
Okay.
progress change, this one is going to happen automatically, so move it. For the burning timer, this one is the value. Okay.
If Burning Timer.
Okay. And finally up here, when modifying, also modify by the value. Okay, we have no more errors. Like this, the client will indeed synchronize the burning timer, but it will not synchronize the state. Now, since we used an enum for our state, we can easily make this a network variable. Enums are serializable, so we can just go up here, make this a network variable of type state, and let's initialize it over here instead of doing it on start. So let's initialize on state.idle.
Certo, pera aí. Aqui. Aqui. Ah, aqui tá bugado, né? Ok.
So let's do this instead of doing it over here on start. And now let's fix.
Tá aqui. Tá, não vai ter mais esse start.
Idle. So let's do this instead of doing it over here on start. And now let's fix some of the usual bugs. So instead of doing a switch on state.value.
Uhum. Certo.
Then for modifying the state, so state.value. For firing the onState change event, let's do the exact same thing. Let's go up here onto the state and the onValue change. Let's do one, so state onValue changed. Let's make this function. So down here on a private void, state onValue change. So we've got a state for the previous state and a state for the new state. So you have this, and over here on this one, let's fire off the local event. So let's cut this and paste it in there. So you have this state.value. Okay, so that is going to fire off all of the events locally, so that's great. Let's keep solving all the errors. So over here, all this logic is already working great. All right, now over here on the fried, let's modify the state.value, and we don't need to modify the state.change. And over here.
Pera aí que eu vou fazer uma cagada aqui no Visual Studio. Ah, aqui, ó. Ei, não. Aí. Mas pera aqui, então eu quero fazer o seguinte. Quero colocar ele aqui. Ou na verdade eu posso fazer o seguinte, né? Eu coloco ele aqui. Ok. E aí eu faço isso aqui, ó. Beleza.
Over here, solving all the errors. So over here, all this logic is already working great. All right, now let's keep solving all the errors. So over here, all this logic is already working great. All right, now over here on the fried, let's modify the state.value, and we don't need to modify the state.change. And over here for the progress change.
Pera aí.
So over here, all this logic is already working great. All right, now over here on the fried, let's modify the state.value.
Nesse onState change a gente não precisa dele, né?
And we don't need to modify the state.change.
Calma, mas estava aqui no... Ok.
And over here for the progress change, we're doing this basically just to hide the progress bar. It gets hidden automatically if the progress normalizes 0f. But again, over here, this code is only going to run the server, so we want to run this on every client. So let's actually put this on the onState changed event, but only when the state is either burned or idle. So let's go up here onto this one. Let's do an if the state.value, if this one is state.burned or state.
Eu não fiz esse negócio aqui, né? Cadê? É isso que eu quero não, né? Eu quero o que eu paguei aqui pra baixo. Esse aqui.
Value if we are on the state.idle. So if you are on either of these states, then let's fire off the progress normalize 0 just so we hide the bar. Okay, great. Now let's fix the remaining errors. So down here on the interact, when we are resetting the state, let's set state.value back into idle. And let's here on the interact. When we are resetting the state, let's set state.value back into idle. And let's get rid of the events since those are already happening. Then over here, same thing, state.idle and get rid of this. And down here on our server and client RPCs, modify the state, so state.value, and the onstate change, get rid of this. Except of course, always remember that network variable, this one can only be modified on the server, whereas here we're working inside a client RPC. So we need to make sure to do this up here, just like that. So by now we can probably just rename this function since all this is doing is setting the frying recipe SO. So let's actually rename this. So let's use the Visual Studio shortcut, just right click and let's go ahead and rename this. Let's call this set frying recipe SO client RPC. Okay, so that will set the frying recipe SO. And then we're also going to need a function just like this for setting the burning recipe SO. So let's just copy this and do the exact same thing. So this one's going to set the burning recipe SO. So get burning recipe SO with input, and this is the burning recipe SO. Also, by the way, one note, several people commented on my single player course, and yes, you could refactor this code to have just a single scriptable object to define both the frying and the burning. You could definitely do that, that is an equally valid option. I just went with this pattern to keep the states a bit more separated so you could potentially expand upon this with more states and more custom logic for each state. Okay, so now let's just call the function to set the burning recipe SO. Also down here, let's fix this last remaining error. Okay, so for setting the burning recipe SO, that one is going to be up here, so the update, the frying, we're going to get the burning recipe SO, but just like this, it won't only happen on the server. We want it to happen on every single client, so let's go ahead, call this. We go into the kitchen game. Multiplayer, the instance, let's get the kitchen object SO index, and let's pass in this kitchen object SO. Okay, so just like this.
É porque, ó, esse cara, ele já tá rodando no server. Então se eu chamar esse cara que é um cliente RPC, vai funcionar de boa. No meu caso ali, eu tava chamando o Interact Logic, que ele ia poder zerar o Frying Timer e o State Value. Que no caso, mesma coisa aqui, né? Se bem que esse aqui já tá. Então nesse caso, esse cara tá sendo chamado aqui também. Pô, ele também podia estar acontecendo lá, né? Então, tipo, isso aqui, só de exemplo, né? Podia estar acontecendo aqui. E aqui chama só o client RPC.
We've got no more errors, so all of this logic should now be working. So let's test. So up here on the host, let's cook something, and there you go, it is being synchronized. Okay, great. Let's wait for the timer to reach the end, and yep, both objects were synchronized as well as that. And there you go, once it gets there, it also spawns the burning timer warning, and yep, both of them get burned and both of them stop. Okay, so with that, everything works perfectly.
Deixa eu ver aqui. Isso mesmo funciona. Dá play aqui. Host. Client. Deu um erro aqui.
Awesome. Now we just have one error. If we go down here on the client and I try to pick up something, there you go, got an error, invalid operation. Basically, it's telling us that the client is not allowed to write to a natural variable. If you look in the code, it's over here on the interact function. When we go down, when there's a kitchen object here and the player tries to pick it up, so this is the issue right here. We have the client trying to set the state value. Again, only the server can do this. So let's go ahead and do this through a server RPC. So a private void set state idle server RPC. Make this a server RPC with require ownership as false. And over here, we just set the state.value just like this. Okay, that's it. Super simple change. Now let's test. So down here on the client, let's go ahead, pick up some meat, drop it, cook it, and there you go, it is working. Let's wait for it to cook a little bit, and there you go, it's cooked. Now pick it up, and there you go, it works, no errors. Same thing up here on the host, pick it up, drop it, everything works perfectly. Wait for it to cook for a little bit, and there you go, it's almost burned, there you go. Now if I pick it up, and yep, there you go, it does work, no errors, nothing anywhere. Alright, so with that, we have essentially all of our counters, all of them fully working. All of the multiplayer state for all of them, all of that is being perfectly synchronized. The interactions work perfectly, except for one thing, which is adding an ingredient onto the plate, so let's handle that in the next lecture. Hey again, quick.
Beleza, pera aí. Houve um equívoco aqui, né? Tá.
We can only one, and here you drop it down just like this. This fall RPC through the player tries. Basically, it's telling us that the client is not allowed to write to a natural variable. If you look in the code, it's over here on the interact function. When we go down, when there's a kitchen object here and the player tries to pick it up, so this is the issue right here. We have the client trying to set the state value.
Ah, tá faltando um aqui, né? Pronto. Okay.
Again, only the server can do this. Drop it. Lecture. People give up by this point, so great job on sticking with it. And actually, if you are following this course, I'm assuming that you've also completed the single player course, so really double congratulations. I really hope these two courses have helped you out a lot in your game dev journey. Now my question is, are you finding this course to be more difficult than the single player or just about the same? Remember to post in the comments if you need extra clarification on anything and I'll do my best to answer. Also check out the website to see what questions others have asked. And of course, remember this is your learning journey. You're not competing with anyone but yourself. So take your time, rewatch some lectures if you need to, just focus on learning. Okay, let's go to the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to synchronize the logic to add ingredients onto the plate. Okay, so right now we already have quite a lot of...
Tá, pera aqui, deixa eu só comentar isso aqui.
of the game logic working in multiplayer. I can pick up items and it's synchronized, I can drop them, synchronize, I can cut some objects, I can cook some meat, everything is working great. The one big thing still missing is picking up ingredients onto a plate. If I go ahead and I pick up a plate and then try to pick up some cheese, and yep, it didn't really work. On the host it looks like it works, but down here, nope, there's no synchronization, so this client does not know that cheese was added to that plate. And if I try doing it down here on the client, so try to pick it up, and there you go, the client does itself get an error. Okay, so let's fix this. For handling that logic, it's on the various counters, so let's go first over here onto the clear counter. Let's go down to where we are seeing if it is a plate. So if the player is holding a plate, then it's going to call this function to try to add an ingredient. So let's see this function. This one goes over here, does a bunch of validation, and then adds the kitchen object so onto the list on the plate. So we really just need to synchronize this. And as usual, we have our two options. One option would be to make the list itself, make it a network variable, or alternatively, there's actually a network list. That would work. We would need to make the kitchen object so serializable, which we could do since we already handled the index functions. So that would be one option. But perhaps another simpler option is simply to use the usual server-client RPC combo. So let's do exactly that. Let's make those two functions. So let's make a private void, call it add ingredient server RPC. And we're going to have another one for the client RPC. Let's add the attributes, so client RPC, and up here the server RPC. And as usual, we want the clients to be able to call this. Okay. Then up here, when we have our interaction, let's trigger the server RPC.
If
And down here on the client RPC, we do this and pass it into that. Okay, so that's our simple. Logic. Now, obviously, down here we need a reference to the kitchen object SO. So as usual, let's receive an end for the kitchen object SO index. Let's also receive it on the client RPC. Over here, we pass it in. Then down here, let's go into the kitchen game multiplayer, the instance, and get the kitchen object SO from the index, and let's grab it from this index. And this is going to be our kitchen object SO, kitchen object SO. And yep, like this, the rest of this code is indeed working. So now up here, let's just grab the index, go into the kitchen game multiplayer, the instance, and get the kitchen object SO index of this kitchen object SO. All right, so that's it. All of this is pretty simple. Now back here in the clear counter, so basically we already handled the synchronization of the try add ingredient. So the next thing is just over here to destroy self. We need to use the other function, so let's just replace this. So going to kitchen object and call destroy a kitchen object, and let's pass in this kitchen object. Okay, so that's it. And same thing down here, let's also replace this function and destroy this kitchen object. Okay. Okay, so just like this, all of the logic should work. So let's test. So first let's test up here on the host. Let's pick up some bread and drop it on a clear counter. Okay, now let's pick up a plate and try to pick up the bread. And if there you go, it did work. It picked up the bread and the client down there does see that this host is carrying the bread. Okay, great. Now let's do the same thing on the client. So down here in the client, pick up some bread, drop it on there, pick up a plate, go and grab it. And there you go, it does work and both of them are synchronized. Okay, great. Now let's do the opposite. So let's drop the bread in there. Let's pick up a plate, drop it in there, pick up some bread, drop it on the plate. And yep, there you go, it does work. And same thing over here on the client. Pick up some bread, drop it, pick up a plate, and let's go ahead, pick up the bread. And yep, there you go, everything does work. All right, awesome. So once again, because the power of writing good clean code, we didn't really need to modify many things. We really just modified one single function and everything already works perfectly. Now really all we need to do is just apply the same logic to every single counter. So let's go here onto the cutting counter, and we have our interact function. Okay, we have the usual interaction, and over here we've got the plate logic. For this one we already handled the try an ingredient, so that
Calma. Cutting counter.
one's already going to be synchronized. So really all we need is just going to kitchen object and use the other destroy kitchen object method. So let's just use this one like this. And yep, that's it. Nothing else we need to change. Next is over here on the stove counter. So again, let's go down into our interact function and let's find where the player has a plate. And really the same thing, the adding the ingredient, that's already synchronized. So let's just replace the kitchen object dot destroy kitchen object. Just replace this one with that one. And then over here, we're also setting the state. So this one is going to give the same error that we saw previously. The client cannot set the state. So that is why a while ago we made this server RPC. So let's just also replace this like this. Okay, so that is why a while ago we made this server RPC. So let's just also replace this like this. Okay, so that should really do it. These are the only 3 counters where the player can pick up something onto a plate. So everything else should already be working. Let's test. So up here on the host, let's cook some meat. Let's also cut some cheese. So both counters. Now pick it up. Let's pick up the cheese. And yep, there you go. It does work. It was synchronized. Pick up the meat. And yep, it also works. Okay, great. And then down here on the client, let's do the same thing. So cut some cheese. It works. Cook some meat. It does work. Pick up the cheese. And yep, it does work. Now pick up the meat. And yep, it also works. Both of them are perfectly synchronized. Then we can even make a delivery, so let's pick up some bread, delivery over here, and yep, there you go, it does work perfectly. Alright, awesome. So with this, the plates are fully working, pretty much everything is perfectly synchronized. Next, we want to sort something pretty basic, handling some player collisions, so let's do that in the next lecture. Hello and welcome, I'm your Code Monkey.
Tá, deixa eu fazer um teste aqui, se tá tudo certo. Eu acabei de testar, né? Deixa eu pegar um café ali.
this lecture we're going to handle player collisions. Okay. So a lot of the game's already working great. I can cook some meat, cut some cheese, and so on, so everything works perfectly. However, one thing we don't have are some player collisions. So right now, the players can just phase through one another. Now this is actually a design question. For some co-op games, they usually have no collisions at all, but some of them do have them. And for this game, I think either approach works. If you want to make it more casual and easier to play, then no collisions works fine. But if you want to make the game a bit more challenging, a bit more rage-inducing in a good way, then adding collisions is a simple way to do that. That allows you to be more complex with your level design by making some small levels where, for example, one player can only go through one tiny corridor. So here, let's add that, and it's up to you if you want to keep it or remove it. Now, thankfully, due to the way we built our game, this is actually going to be super simple, so this is going to be yet another quick lecture. Over here on the player script, if we go down into our handle movement function, so let's go down to this function, so here it is.
Aqui, player. Okay.
For this one, we are already testing for collisions. We're doing a capsule cast to see if we can collide with something, see if we can move or not. So this code is already working, but actually let's first refactor this code to be a bit more adaptable. I saw some people trying to expand upon the single player game by adding some trigger colliders to do some extra logic. And like this, using this capsule cast, this cast will hit every single collider, so that means all of the counters as well as any other colliders that you probably don't want to hit. So to solve that, let's use a layer mask to make sure we only collide against things we want to collide with. So the layer mask is going to be exactly like we did up here on the handle interactions. We made a layer mask just to be able to hit some counters. So let's do the exact same thing down here. Let's look at all the versions of the capsule cast to see which one we can use. So let's use this one down here, version number 4, which is exactly the same, so has the same parameters, and at the end we have a layer mask. So at the end we can just add, and we can just reuse the counters layer mask. So let's do that, and this way this capsule cast will only hit things on the counters layer. Let's make sure to apply it here, as well as these two other capsule casts. So on this one, and also the one down here. Okay, so let's do a quick test just to make sure that nothing really changed. So here I am, I can move around, and yep, it is indeed testing for collisions. Okay, so far so good. Except now, if we wanted, we could add some things. So let's say I would add a cube. This one has a box collider. I don't want any visual. So let's say this was just a trigger collider. So I wanted to place it somewhere in here. As long as this one is not on the counters layer, as long as it isn't, then over here on the game, I can move around, and yep, there you go. There's no issues. I can go through that invisible cube. So this allows you to expand upon the game in order to add some more logic based on colliders. Okay, great. So back to our original goal. Let's add some player collisions. Right now, this is only testing against counters, and all we really need to make this work is also test against players. But for the interaction up here, we still only want this one to hit just the counters. So really, let's just make 2 layer masks. So up here we have the counters layer mask, and let's go with another one. And for this one, let's go with a more generic name. So let's say collisions layer mask. Okay, so we have this. We're going to set this in the editor in a little bit. Let's just go down here and really just replace it with this one. So replace it on that one, and over here on this one, and then down on this one. Okay, great. That's it. There's nothing else we need to change in the code here. And now if we go in the editor and we select the player prefab, and even down here we have the collisions layer mask, so let's make sure to include the counters. And now we also to include the players. So let's go into our layer, let's add a brand new layer. Let's call it the players layer. Then over here on the player game object, let's put this one on the players layer. And for this case, let's not apply it to all childs. Let's leave the children on the same layer they are, so let's apply it to this object only. Okay, so this one is on the players, and on the collisions layer max, let's just include down. Okay, that's it. Now really all we need is just a physics shape, and we can use whatever shape we want. Since we made the movement work with the colliders on the counters, which are really box colliders, over here let's use the same thing. Let's also use a box collider. Let's actually go inside the player prefab so we can scale it. And now here, just a quick tip. Usually for physics colliders, you want to make them a bit smaller than the visual. Usually that makes for a better experience for the players. So up here, this one is a bit too big, so let's make it a bit smaller. So on the X, let's put it on 0.7. On the Y, we can live with 1, and Z of also 0.7. So it's a bit smaller than the actual visual. Now let's also lift it up by half of the height, so let's put it up on 0.5. So there we go, it is exactly like that. By the way, important, make sure that the collider is essentially touching the 0 on the Y. So up here, don't lift it up by more than half the height. That is because at the bottom, that is where we're finding the cast on the player. If you lift it up by too much, it might not hit it.
Vou botar uma cápsula, né? Não vai. Ele tá menor, ok. Vamos ver se funciona.
Depending on the size you use. Okay, so that's really it. If we test it just like this, let's just exit, save the prefab, and let's test. So here I have two players, and moving around, it still doesn't go through the counters. Okay, great. Now if I go into the player, and there we go, now it no longer goes through the players. Alright, so that's great. It works over here on the host, and down here on the client, same thing. It also does not go through. Okay, awesome. Now, one more minor thing. For the collision detection, for the player shape, we used a capsule. Now, in most cases, this is actually a good shape for the player, but due to how we handle the collision detection here, how we handle that code for checking the X and Y in order to make it easily slide around, this method is indeed great, but it works best on straight colliders. Meaning that if I try to hit the player on the corner, like this, there you go, look at that, the player is stuck. I try to move straight down or straight to the right, and nope, it does not work. Basically, that's because the capsule collider, that one has a round edge. So if we hit perfectly on the corner, based on the code that we have here, it will not slide around, it will just be stuck. Some people mention this in the single player course because they made the map different from mine. In my map, there's never an issue because there are never any corners. But if you do have corners, then yep, swapping it out makes sense. So one option would be we could modify the collision detection code to work better against some corners. We could use the collision normal to move or something like that. Or perhaps a similar approach, let's just refactor the code.
Ei. Oxi. Aí.
To option would, but if you do have corners, then yep, swapping it out makes sense. So one option would be we could modify the collision detection code to work better against some corners. We could use the collision normal to move or something like that. Or perhaps a similar approach, let's just refactor the code to, instead of using a capsule cast, to use a box cast. That way we don't have any round corners. So back in the player code, instead of using a capsule cast, let's use a box cast. Then just need to modify the parameters. Let's use this one, version 6. So first parameter is the center, so let's use transform without position. Okay, great. Then the half extends. For this one, let's use vector 3.1. This is just a shorthand for writing 111. So let's do this multiplied by the player radius. That way we have the box cast size. So next we have direction, so that is going to be the move there. Then we have the quaternion. This is the rotation for the box cast. We don't want any rotation, so let's just use quaternion.identity. This essentially means no rotation. Then we use the move distance and the layer mask collisions. Okay, that's great. So this is exactly the same thing. So let's use the exact same parameters down here. So we use a box cast. Let's use the same version 6. So we have that. Then for this one, we have the vector 3.1 times the player radius. Then the move the x.
Center, half extends, direction.
Then we have quaternion.identity. And then we have the other two. Okay, great. And same thing down here. Also a box cast. Then replace the point 2 with this one. Then we have the move there. And again, quaternion identity, just like this. Again, make sure you don't make any mistakes on the parameters. I saw a bunch of questions in the single player course because a bunch of people got confused over here with move their X and move their Z. So make sure you don't make any mistakes. So that's it. Let's test this. Okay, so here we are, and if I touch the player from a corner, and there you go, it no longer gets stuck. So if I go straight into a corner, now the code does behave the same as we have up here on the corners. So it goes in and it slides around either up, down, left, or right. All right, awesome. Okay, so that's it. With this, everything already works perfectly. Just one thing, which is the fact that when they spawn, they both spawn in the exact same position. So let's just make a minor change to make them spawn on different positions. This is also super simple. Over here on the player script, let's go down into our onNetwork spawn function. And over here, to know the player name, we can just access the owner client ID.
Pera aqui.
Over here on the player script, let's go down into our onNetwork spawn function. And over here, to know the player name, we can just access the owner client ID. We can basically use this as an index in order to access a list to get the position. So let's remove that just so it compiles. Let's go up here, make another serialized field. A private, let's make it a list of vector3, and call it the spawn position list.
Tá, pera aqui. Private.
Then back here in the editor, let's select the player. And on the player script, let's put in 4 elements, so 4 positions. We're going to have 4 players. For the first one, -2, 0, 0, then +2, 0, 0, then -2, 0, and -2, and +2, 0.
Oi, Toninho. Vem cá.
-2. So we have 4 positions. And over here, it's pretty simple. So we just set the transform.position, and we go into the spawn position list and access it on the index of the owner client ID.
Ok, então pera aqui, onNetwork spawn. Transform.position é igual spawn bound list de índice owner client ID.
And this one is a long, not an int, so we can just cast it down to an int. Okay, that really should do it, so let's test. So up here, connect as the host, and yep, it's on that position. Down here on the client, and yep, there you go, it is on that position. Alright, great. Now I should point out that this code actually causes an error if a player disconnects and another one connects. That is because the owner client ID, this one is not really sequential. But don't worry about that for now, we're going to refactor this code later on when we handle the lobby and the character selection. Okay, so here we have our perfect collisions between all of our players. Again, like I said, this is a design decision, so it's up to you whether you want to keep it or disable it. You would just go into that layer mask and either include or not include the players, so that's it. And with that, we have pretty much our game completely synchronized. The one thing we still don't have synchronized is the game state, so the countdown, starting to play, game over, and so on. So let's do that in the next lecture.
Ok. Deixa eu testar aqui, né? Ok, funcionou belezinha. Sync player.
Hello Hello and welcome, I'm your Code Monkey. In this lecture we're going to synchronize the game state. So that's the waiting, game start, game timer, and game over. Okay, so we already have quite a lot synchronized, but one of the main things that is not synchronized is the game state. In the beginning of this course we skipped the states just to make testing easier, so let's get those back now. Let's go over here onto the Kitchen Game Manager, and let's remove the auto start code, this debug trigger that we added quite a while ago, so let's get rid of this. And
ok. Kitchen Game Manager. Tá, isso aqui eu tinha botado. Ok.
And for the countdown timer, let's reset this one back into 3F, and that's it. And for the countdown timer, let's reset this one back into 3F, and that's it, nothing else. Okay, so let's test. Okay, so it starts off, and yep, it is indeed showing the controls, and as I interact, yep, there you go, it starts the countdown. Okay, so it's back to normal, except obviously now this one is actually playing the game, where this one down here is still staring at the controls. We want to synchronize these two states. Basically, we want to start off by showing all of the players the controls window, then as each player presses the interact action, instead of going to the countdown on that player, instead of that we want to go to another state, waiting for all of the players to be ready, and then when all the players are ready, then we do start the countdown. So let's do that. Over here in the Kitchen Game Manager, basically we need another state for when the player is ready and waiting for the rest. So one option could be to make another state here for waiting for the players to be ready. However, actually in a little bit we're going to synchronize this state across all of the clients in order to synchronize the countdown, the game playing, and so on. So since we're going to synchronize this same state across all the clients, we cannot have one that is different on a per client basis. So instead of adding a brand new state right here, let's just make a simple boolean. So a private bool, let's call it is local player ready. So we have this, and then down here when we have the interact action, instead of going straight to countdown start, instead of this one, let's just set is local player ready into true. Okay.
Calma.
So now to countdown start.
Ok.
Instead of this one, let's just set is local player ready into true. Okay, so now we want to hide the tutorial when this player is ready. So for that, let's basically fire off an event and then expose this boolean. So first of all, let's expose this boolean. Let's go down here and make a public bool is local player ready. And we just return the is local player ready. Okay, so we return this, and then up here let's make an event. So a public event handler, let's call it on local player ready changed, and then down here when we have our input over here, let's invoke this event. Okay, so we have
Ok. Então aqui
this event. Now let's go over here onto the tutorial UI script, and previously we were listening on the state change, and we were only hiding the controls when the countdown was active. Now we don't want this one, so let's go into the Kitchen Game Manager instance, and this time it's the on local ready player change. Now let's go over here onto the tutorial UI script, and previously we were listening on the state change, and we were only hiding the controls when the countdown was active. Now we don't want this one, so let's go into the Kitchen Game Manager instance, and this time it's the on local ready player change. So let's just rename this to the Kitchen Game Manager. Okay, we have this function, and then over here if, let's go into the Kitchen Game Manager. The instance, and let's test if the local player is ready. If so, then let's hide this, and we no longer do anything on the state.
Ok, pera aqui. Então F Kitchen Game Manager.instance.is local player ready. Fortnite. Ok. Eu não faço mais isso aqui.
They changed. Okay, yep.
Deleta
If
ali.
so, then let's hide this. And we no longer do anything on the state changed. Okay, yep, just like this. And now, by the way, some of you might be thinking, if we have this event, why do we need to test for the boolean? Couldn't we just hide it when we get the event, regardless of any boolean? And yep, that would indeed work. The only reason I did it this way is just in case you want to add the ability for the player to unready themselves. In this case, I made it stay stuck in ready, but you could easily modify this to let the player go back. By combining the event and the boolean, you can easily add that feature. Okay, so with this, the tutorial UI should hide. Now we just need some visual to tell the player that they are waiting for the others. So back in the editor, let's go inside the canvas. And let's start off by duplicating the tutorial UI. So let's duplicate this. And let's zoom in the camera, put it in 2D and go in there. Okay. For this one, let's call this the waiting for other players UI. And let's put it on the same sorting order, so just under the tutorial UI, okay, like that. And over here, we basically just want some text, so let's just keep the same background and get rid of all these objects. And instead, let's create a new UI text. And for the text, let's say waiting for players. Let's put it in bold. Let's put that one, put it on overflow down the center. Let's put it in black and lift it up a little bit. Okay, so very simple window.
Okay.
Now let's make the script to run this, so with the exact same name. So let's go into our UI. Folder, and let's create the brand new C# script, waiting for players UI. Then on the game object, let's not forget to get rid of the old tutorial UI. Instead, let's set
Delete aqui. Bota esse. Ok.
this one, so waiting for other players UI, and let's open this script. Now over here, let's begin by making the usual show and hide functions, so private void show, and then a private void hide. And over here, game object set active into false, so the same thing we've already done so many times, okay? So we have this. Now let's listen to the local player ready event, so let's make a private void start, go into the kitchen game manager, and let's listen to the on local ready player changed. Let's just rename this to give it a proper name. Okay, so we have this one. Then let's do the same thing. So the instance is the local player ready. If so, then let's show. Okay, so that.
Tá, pera aqui. Eu pego errado, né? Kitchen Game Manager. On local player game ready.
Handles the showing, which by the way over here on start, we listen to the event and then we hide it, okay? So it will start off hidden by default and then show when the player is ready. Then we need to know when to hide it, and that is going to be when the countdown actually starts. So let's also go into the kitchen game manager instance, and let's subscribe to the on state changed event. So let's go kitchen game manager. Okay, so we have this event, so when the state changes, let's test if the event is on the countdown to start active. So if the countdown is active, then let's hide this window. Okay, so that's it, pretty simple. Let's do a quick test. So here we are, and both of them are
Tá, aqui pra onde eu teria que ter um rádio também, né? Se for outro.
okay, so that's it, pretty simple. Let's do a quick test. So here we are, and both of them are looking at the controls. Now I press interact, and there you go. Instead of starting the countdown, now it is waiting for players. Same thing down here, interact and waiting for players. Okay, so far so good. Now we basically just need to check if all of the player states, if all of them are ready in order to know when to start the game. Now there are actually many ways we can do this. Basically, we just need to synchronize a simple boolean to know when a player is ready. The only tricky part about this is it depends on how you want to handle the number of players. So do you want the game to forcefully only work with 4 players, or maybe 2, or make it work with any number? That's another design question that will impact what data type you use. So over here, let's make it work with any player amount. Back in the Kitchen Game Manager script, over here let's use a dictionary, that way we can support any number of players. And also the reason for using a dictionary instead of a list is because the player client ID is not necessarily sequential. For example, if one player connects and then disconnects, it will not reuse that ID. So if in the end you end up with 4 players connected, it is not guaranteed they won't have IDs 0 through 3. So because of that, a dictionary using a client ID for the key, that one is a much better approach than using a network list. Okay, so let's build our dictionary. So a dictionary for the key, and let's use YOLONG, which is the type for the client IDs. And for the value, let's use a simple boolean. So let's call this one the player ready dictionary. Okay, so we have this, and over here on awake, let's initialize our dictionary. So by default, all of the keys with all of the possible client IDs, they're all going to be unset. Then down here, when we have the interact action, when we set this player to ready, over here, let's tell the server that this player is ready. So for that, as usual, let's make a server RPC. So a private void, let's call it set player ready server RPC. And as usual, mark this as a server RPC with require ownership as false. Okay. And now in order for the server RPC to work, we need to make sure to mark this one not as a mono behavior, but as a network behavior. Okay, great. So we have our server RPC. We just need to also go back here in the editor. Let's select the Kitchen Game Manager, and yep, let's set the network object component. Okay. Great. So now here on this function, basically the server needs to know which player is ready. So technically up here, when we call this function to set its player as ready, when we call this function, we could pass in the owner client ID. This is going to contain the client ID of the player that set the ready. So this could work, but on the Unity docs themselves, they don't encourage this. The reason is because technically a hacker could fake their client ID and possibly break everything. Now in this simple co-op game, we're really not worried about hackers, but still let's do it the proper way. So instead of having the client send its own owner client ID, instead of that, let's go down here into the server RPC, and let's add a parameter of type server RPC params. This is a built-in type, part of Netcode for Game objects. So let's receive this one as a parameter, and let's just default it. meaning that up here we don't need to pass in anything, it gets defaulted. Then now here, when we're on the server side, we can access the server RPC params, and inside we've got a receive and a send. So in this case, the server is receiving the server RPC, so let's go inside the receive, and over here we have the sender client ID. This is going to be the ID of who sent this server RPC. We can do a quick log just to verify, so let's do a debug.log on this server client ID, so let's see. Okay, so up here on the host, if I press the button, yep, there you go, the host sent the sender client ID, which is 0. And now down here, if I interact, that one should say 1, which should be default client ID for this one. So interact, and there you go, got the 1. Okay, great. So with this, we know which player set the ready. Now to sort that is really super simple. Let's just go inside our player ready dictionary, and let's access it on this key, the key of this sender client ID, and let's just set this to true. So this will set the player ready for this client ID. Then we just need a basic loop to check if they are all ready. So let's do a for each to cycle through all the clients. So ulog for the client ID, and let's do a for each inside the network manager. Let's go inside the singleton, and let's cycle through the connected client IDs. So this one.
Isso, network manager. Eita.
Go through every single client ID. Then over here, let's do a basic test to see if this client ID is not ready. So if, and there are two ways that it can be not ready. So it can either have false on that key, or it can simply not have that key at all. So let's go into the player ready dictionary, and let's test contains the key of this client ID. So if it does not contain that key, then this one is unready. Or it does contain that key, but that key is false. So on the client ID, is false. So if it is like this, then this player is not ready. So to check if they are all ready, up here, let's first find a boolean. Let's say all clients ready, and let's default it to true. And over here, if just one of them is not ready, then we set this one to false, and let's break out of the cycle. Okay, so then down here, now we know if
Aqui dá break.
all the clients are ready. So let's do a debug.log, just see this. So all clients ready, and let's print the all clients ready. Next one over here, I forgot the not. So if it does not contain this key, or this one is not ready, then this one is not ready. Okay, so with this, let's test. Okay, so here we are with the host.
Analisa aí, você não tem que pilotar primeiro. Host client. E aí eu vou dar tipo ready aqui no cliente. Ué. O console.log aqui não funciona muito bem não. fazer o contrário. Deixa eu pôr isso aqui no host, isso aqui no cliente. Kitchen game.
Host and the client. Now if on the host I set it as ready, and if there you go, all clients are ready is false because only the host is ready. But now down here, if I'm ready on this one, and if there you go, all clients are indeed ready. Alright, awesome. So with this...
Ah, tá, não chamei a função aqui, né, tá explicado.
So all that's left is really to start the countdown. And for doing that, we have two options. We can use a client RPC to tell all of the clients to go to the next state. That's one option. However, that wouldn't be very good. Basically, we would end up with each client having their own local state. However, that wouldn't be a client with so all clients.
Ah, tá. Aqui é o contrário, né?
Clients ready. If it does not contain this key or this one is not ready, then this one is not ready. Okay, so with this, let's test. Okay, so here we are with the host and the client. Now if on the host I set it as ready, and if there you go, all clients are ready is false because only the host is ready. But now down here, if I'm ready on this one, and if there you go, all clients are indeed ready. Alright, awesome. So with this, all that's left is really to start the countdown. And for doing that, we have two options. We can use a client RPC to tell all of the clients to go to the next state. That's one option. However, that wouldn't be very good. Basically, we would end up with each client having their own local state. Technically, that could work, but I think it makes more sense for the state to be synchronized just once for the whole game. So instead of synchronizing both the state as well as the timers, instead of doing that through client RPCs, I think it makes more sense to use network variables. So let's do just that. First, let's go here on the state. Let's make this a network variable. And because
Tá, pera aqui.
state is an enum, we can just make it directly like this. So let's make
Ok. Network variable.
a new state. And for default, instead of defaulting it down here on wait, let's default it up here. So default on waiting to start. Okay, we do that instead. Okay. Now let's fix the remaining errors. So over here, when we have the input, let's get the state.value. Okay, and then down here on the update, for this update, this logic is only going to run the server. So let's test if not is server, if this one is running. not on the server. Let's return, so we don't want to do anything outside the server. Then we do a switch on the state.value. We do a bunch of things. Then we modify the state.value, and over here modify the state.value. Okay, let's see some more errors over here. All of them pretty much the same thing. We just have to access the value in order to fix all of this. Okay, so that solves all the errors. Now, an important thing is, since over here on the update, we made it so that only the server runs this code. Just like this, only the server is going to fire off these events. We need to modify where we are firing this, since we also want the clients to listen to these events. So let's listen when the network variable changes. So let's go up here, and as usual, let's first of all make an override for the on network spawn. So we have this one, and then let's go into that one. So that's the state. So state.onValueChanged. Let's make a function called state.onValueChanged. And let's use Visual Studio over here to auto-generate the function. Okay, so here it is with the previous value and the new value. And when the value changes, when the state changes, then we fire off this same event. So just like this, and get rid of all of these instances. Yep, only this one, just like this. Okay, so modify the network variable, and all of the clients are going to listen to this event, which in turn fires off this local event. So just like this, all of the clients should have all the states synchronized. Now we can go down here to when we are setting the play ready. So if all the clients are ready, if so, let's modify the state.value, and let's begin the countdown. So let's go. Go into not waiting to start, but into the countdown to start. Okay, so just like this, it should work. So let's test. So here we are, and on the host, I'm going to set as ready, and there you go, it's waiting for players. Now down here, I'm going to press, and it should start the countdown. So let's press, and there you go, all of them are ready, and we've got our nice countdown. Okay, so that's great. However, if you notice down here, the client, that one was stuck on the countdown timer of 3, and we also noticed that the timer over here is not being synchronized with that one. So let's synchronize both these as well. Basically, we have the countdown timer and the game playing timer. We need to synchronize both these, so let's make them as network variables. So this is one, and this one is another one. For the countdown time.
Okay.
Timer, let's do a new, let's start.
Ah tá, tô faltando um new, né?
Start off on 3F, and for this one do a new, and start off on 0F. Okay, now let's clean up all of these errors. So let's see, down here this is the server code, so let's just do value in order to test that one. And same thing for here, and same thing on this one, pretty much just have to modify to access the value like that. And same thing on this one, pretty much just have to modify to access the value like that. And down here to get the countdown timer, get the value, and over here same thing, get the value. Okay, so that fixes all the errors. And let's also go up here in order to also test out the game over state. Let's go for the game playing timer max. Let's put this one just on 10F, just for testing. Okay, so let's test. Alright, so up here let's connect the host, then on all of these, let's make them clients. Okay, great. Now if I ready, let's say on this one, if I ready, yep, there you go, waiting for players. Now I go into this one, ready, yep, still waiting for players. Now I go into this one, ready, and yep, still waiting, they're all waiting for the last one. And as I ready this one, yep, it started playing the countdown timers, they're all synchronized, and the game starts, yep, and over there we can see the timers, yep, those are also being synchronized. And as soon as they reach the end, let's see if they all synchronize the game over state. As soon as they reach, yep, there you go, we have the game over. Alright, awesome. Okay, so here we synchronize the main game state, waiting for all the players to be ready, synchronizing the countdown timer, the game timer, and finally the game over. Now, just one more thing, there's a minor bug that I only noticed right now. If instead of setting ready first on the host, if we set it first over here on the client, and then set it as ready on the host, yep, there you go, this one says stuck on the waiting for players. So let's fix this. This is a super simple fix. Basically the issue is that when this event is fired, that's when that window becomes active. But when we set the play ready server RPC, that one, if all the clients are ready, is going to trigger this start countdown. So basically when this one happens, that window hides itself, but then this code runs and that window shows itself. So just a minor issue, and the simple solution is just make sure to fire the event before we set the server RPC to send the ready. So if you do it like this, now here on the client, let's go ready, on the host go ready, and yep, there you go, everything works. Okay, great. Now before we end this lecture, let's just go over here to the game playing timer max, and let's reset this back to the normal value of 90 seconds. Okay, so with that, the game state is all working perfectly. One thing we still don't have synchronized is the pause state, so let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to synchronize the pause state. So here we have our game where we already have tons of stuff already perfectly synchronized. However, if I pause the game on this one, and if there you go, now this one is still playing and everything still works. And if instead of pausing on the server, if now I pause over here on the client, So the client is paused, but the server is still moving, and we can see over there the countdown timer is still moving. So we need to sort this out some way, and for the pause, multiplayer games can handle it in different ways. The simplest option is simply to not allow pausing at all. Adding that ability is super easy. We're handling the pause over here on the kitchen game manager. So we have over here, we have a toggle pause game, and when we pause, we set the timescale to 0, and when unpause, set it back to 1. So the simple option to not allow pausing to modify the game state would be just to not do this, so we don't modify the timescale. That's the simplest option. With that, basically the local player can check the settings and so on, but for everyone else, the game will keep playing just the same. So this is the simplest option that a lot of games implement. The main reason for that is usually to keep things fair. If you have, for example, a shooter game, you don't want one player to pause just as the other player is winning, so in those games pause usually doesn't happen. But on a co-op game, like the one we have here, usually you do want to allow pausing just because it's a useful feature to have, and in co-op it's not much of a problem as it is in PvP games. So let's go back to our code, and let's also implement some simple pause syncing, meaning that any player can pause the game, and the other players will need to wait for the game to be unpaused. How we do this is actually pretty simple. We're going to do pretty much exactly the same thing that we did for the player ready logic. We're going to have a dictionary. If all of the players are unpaused, the game is going to unpause, and if at least one of them is paused, then the entire game for all the clients will be paused. So first of all, we need to tell the server if we want to pause, so let's use a server RPC. So a private void, let's call it pause game server RPC. This one will be a server RPC with require ownership as false, okay? Then just like we did with ready, the server needs to know which client paused the game. So let's receive the server RPC params, and as usual, let's put it as default, okay? So we have a pause function, and we're going to have another one pretty much exactly the same for the unpause. Okay, we have these two, and up here when we do this, let's trigger a pause and trigger the unpause. Okay, so now for storing the pause state, let's use a dictionary just like we saw. So let's go up here and let's make another dictionary. It's going to be exactly the same, so we're also going to have a YOLONG for the client ID and then a boolean for is player paused or unpaused. So let's call this the player pause dictionary, and let's initialize it. So up here, let's do a new dictionary. Okay, so we have this, and then down here pretty much exact same thing. So let's go into the dictionary. Let's use the server RPC params on the receive. Let's grab the sender client ID, and for pause, let's set this one to true, so this one is paused, and this one will be unpaused. Okay, so with this now the server knows which players are paused and which are unpaused. Then let's make a function to see if any of them are paused. So let's make a private void, call it test game paused state, and over here let's cycle through all of the client IDs. So let's do the usual for each. YOLONG for the client ID in, and let's go into the network manager. Let's go in the singleton, and let's grab the list of connected client IDs. So we have this. Now let's see if any player is paused. So if the player pause dictionary contains a key with this client ID, so if it has a key and the player pause dictionary on this client ID. If that one is true, that means this player is currently paused, so this player is paused. If so, then we're going to want to pause the entire game. And if we get down here, so we do that and then let's return. We don't need to go through the for each anymore. And if we do get down here, then at least all the players are unpaused, so all players are unpaused. And of course, we're going to run this function after we set one of these. So after a player pauses or unpauses, we run this code to test if the entire game should be paused or unpaused. So now all that's left is to tell the clients to either pause or unpause their game. We can do that either with a client RPC or we can use a network variable. For this one, let's use a network variable. So up here, let's go and we have the isGamePaused. Let's rename this to be more accurate. This one refers to the local player. So let's rename this and instead let's name it isLocalGamePaused. And then we're going to have a network variable for the actual network state. So private network variable of type bool for isGamePaused. So we have this one and start off as false, so the game starts off unpaused. Then we can go and start off as false, so the game starts off unpaused. Then we can go down here into the function testing the pause state. So if at least one of them is paused, then we can go down here into the function testing the pause state. So if at least one of them is paused, let's go into this one .value and set it to true. And if all of them are unpaused, let's set this one into false. Okay, so that's really it. Now we can listen to the event when this network variable changes. So let's go up here to our on network spawned. Let's go isGamePaused and let's listen to the on value change. So isGamePaused on value changed. And let's use Visual Studio to write out this function. So here it is, okay? Now when this one changes, now here we can set the actual timescale. So if isGamePaused.value, so if the game is paused, let's set the time.timescale into 0f because the game is paused. And if not, let's set the time.timescale into 1f. Okay, so with this, the pause state and the timescale will be synchronized across all the clients. Let's just go down here because we don't want to make sure to modify that somewhere else. So down here, let's get rid of the timescale and this timescale. Now for these events, we're using these events in order to show the pause window. So these are still useful. Let's just rename them to make them a bit more accurate. These are only going to be fired based on the local pause state. So let's rename this to on local game paused and this one on local game unpaused. Now let's rename also the listener functions. So it's over here on the game pause UI. So we have these functions. Let's rename them quickly. So on the game pause UI. So we have these functions. Let's rename them quickly. So on local game pause, and over here for this one on local game unpaused. Okay, so just like this, the game pause window should be working correctly. So the local pause should be working with a nice visual, but we also want the visual to reflect the synchronized state. We need something to say that it is waiting for all of the players to unpause. So back in the editor, let's go in with a nice visual, but we also want the visual to reflect the synchronized state. We need something to say that it is waiting for all of the players to unpause. So back in the editor, let's go inside the canvas, and let's begin by duplicating the game pause UI. So let's duplicate this one. Let's name this the pause multiplayer UI. Then inside, let's keep the background, keep the pause text, just get rid of these buttons. And for the pause text, let's just say waiting for all players to unpause. Let's put it a little bit smaller. Okay, so like this. Then for the sorting order, let's put this one behind the game pause. So let's put it right above there. Okay, great. Now let's make sure to remember to get rid of the pause. So let's put it right above there. Okay, great. Now let's make sure to remember to get rid of this script, and we're going to make a script to run this. So let's go into our scripts, create a brand new one with the same name, so pause multiplayer UI, and let's attach the script, so the pause multiplayer UI, and let's open. Now here, let's begin making the usual show hide function, so private void show, and a private void hide, and game object set active either into false, or up here into true. Okay. Now we need to know when to show this one, so we need to know when the global game state is paused. So back here on the kitchen game manager, let's just make some more events. So let's make a public event handler. Let's call it on multiplayer game paused and on multiplayer game unpaused. So we have these two events. And for these, we're going to fire them when the network variable changes. So over here is game pause on value change. So on this one, invoke. So this one is going to be paused. And on this one, it is going to be unpaused. So the on multiplayer game unpaused. Okay, so we have these two events. And now back in the script, let's just listen them as usual. So make a private void start. On start, go into the kitchen game manager and listen to the on multiplayer game paused and unpaused. Let's just rename this to give it a proper name. So kitchen game manager. And then the other one, so same thing on the instance on the multiplayer game unpaused. Let's rename this one as usual. Okay, we have our two events, so when the multiplayer game is paused, let's show, and when it is unpaused, let's hide, and on start, after we listen, let's hide. Okay, so that's it, pretty simple. Let's test. Okay, so here we are, I have the host and two clients. Now if I pause on the host, yep, there you go, all of these are waiting for on player. Players to unpause, and if I unpause on the host, yep, there you go, the game is back to normal. These are waiting for all players to unpause, and if I unpause on the host, yep, there you go, the game is back to normal. Now if I pause on this one, yep, there you go, the game is indeed paused, and we can see over there the timer is not counting down, so yep, everything is indeed paused, and if I try moving, also doesn't happen because the game is paused. Now let's go into this other one, and let's pause this one. So now two of them are paused. Now up here, if I unpause this one, yep, there you go, still waiting until I go down here. I unpaused, and yep, there you go, everything back to normal. The timers are running, everything is working. All right, awesome. Okay, so here we implemented some nice pause syncing. This way our co-op game is very friendly to people who might have to pause an online game for any reason. Now, one scenario we still haven't handled is what happens when a client disconnects, so let's sort that out in the next lecture.
Tá, o único problema é que... Opa! O único problema é que atualmente a tela... Esse é o pause multiplayer, ok. E esse é o game pause. On local player pause, ok. Esse cara deveria se esconder se esse cara aqui... Calma. On multiplayer pause. Ah, tá, pera aqui que não existe essa função. Essa... Só vou mostrar essa tela se não tá pausado. Só pra testar aqui. O problema aqui é o seguinte, se eu abrir mais uma, pera aí que aqui o state ficou errado, né? Host, client, pronto. Pausei nesse. Ah, eu deveria esconder ele. Uhum. Mas enfim, se eu der resumo nesse. Esse cara que não tá esperando. É, tipo assim, eu tenho que ter mais dos eventos ali sendo ouvidos. Mas eu vou deixar assim por enquanto, tá bom.
Hello and welcome, I'm your Code Monkey.
Tá.
In this lecture, we're going to handle player disconnects, and this is actually going to be super simple. Okay, so our multiplayer game is really coming along. Now, in single player, we don't really need to worry about the player randomly quitting, but in multiplayer, we need to make sure that the game actually keeps working correctly if a player does decide to leave. So for example, if down here on this client, if I just close this window, and right away we can see that it does work very well, so the player object was removed from the world, so it looks like it already works. Basically, when the player disconnects, all of the network objects that player owns are destroyed with them, so the player prefab is destroyed automatically. Really, the only issue we have is if that player is holding something. So if down here on this player I just pick up some meat, and now I quit, and if there you go, now we have some meat holding along in midair. That's the issue that we have to solve. The player object is destroyed automatically, but we need to make sure to manually destroy the kitchen object the player is holding. So for that, let's go here onto the player script. And first, we need to know when a player disconnects. And for that, we can access a callback. So let's go over here onto the on-network spawn. And we're going to go into the network manager, access the singleton. And over here, we've got a callback on client disconnect callback. So let's listen to this one. Let's rename this to network manager on client disconnect callback. Okay, great. And for the ulong over here, this is going to be the client ID. So the client ID of the client that was disconnected. And we can see over here on the documentation, this callback will be ran both on the server and on the local client that disconnects. Now in this case, for the client that disconnects, we don't really want to worry about them, so we really just want to listen to this on the server. So we can just add here if is server, and if so, we're going to listen to this. Also remember that the is server here, this one refers to the state of this build and not this specific player, so this will still attach a listener on the server side, even on players that aren't actually the host. Okay, so with this callback, now the server knows when a player disconnects. With the client ID that we have here, we can check if this is the one that was disconnected. So let's check if this client ID, so the one that disconnected, does match the owner client ID. So if so, then it was this one. Then next thing we want is to check if this player is holding any kitchen object. So if it is this one and has kitchen object, if so, then we want to destroy it. So as usual, let's use the kitchen object and destroy the kitchen object and pass in this dot kitchen object. We can only destroy on the server, but over here we already attached the listener only on the server, so yep, this should be working. Okay, so just like this, let's test. Okay, so here with the client, let's pick up something, and now let's quit on the client, and yep, there you go, the object is indeed destroyed. Alright, awesome. So just
Que mensagem é essa aqui? Network Simulator Implementation Disabled.
Just with this, we already have the entire game logic working perfectly with disconnects. There's nothing else the player can do that could affect the gameplay itself. If they disconnect in the middle of cutting or frying an object, that doesn't cause any issues. The one thing that can cause issues is if they pause the game and then disconnect. So here are both, and down here on the client I'm going to pause the game, and then I'm going to quit. And if there you go, this one did clean up the player, but now this one is stuck waiting for unpause. Now thankfully, the way that we handle the pause synchronization, we made it over here by cycling through the network manager connected client IDs, meaning this is actually only going to test the state for the actual connected clients. So because of that, this here isn't actually a game breaking bug. If on this remaining client I just pause and unpause, and if there you go, now the game is back to normal. But obviously it should automatically unpause if the only pause player quits, so let's fix that. This is also going to be a pretty simple fix, so let's go over here onto the kitchen game manager. This is the class where we're handling all of the pausing. So on this one, just like we did on the other one, let's listen to the disconnect callback. So over here on the on network spawn, let's check if is server. So on the server, let's listen to it. So network manager, the singleton on disconnect callback, and let's listen to it. And as usual, rename this, keep things clean. So network manager. Okay, so we'll listen to this. And over here for the parameter, this is the client ID. Although right now we really don't need the client ID because afterwards we really just need to run the function. Test the game pause state. This will then test all of the clients and see if any of them are paused, and if the one that disconnected was the only one that was paused, then this will unpause the game. However, this won't actually work. The reason is because when this callback is fired, when this happens, the client is still going to be on the connected list. So if it cycles through this, it's still going to cycle through the client that is just disconnecting. So basically to solve this, we need to wait one frame to make sure that this list is updated. So let's basically make a boolean, and then after that update, then we're going to run this function. So up here, let's make a private bool, call it auto test game paused state. We're going to test that automatically. So then when we have our disconnect, let's set this one into true. And over here we are not going to run this function. All right. Then let's go down and we're going to make late update. So let's go over here, a private void late update. And on late update, let's check if this one is true. If so, then first of all, let's set it to false. And over here, we run the test game pause state. Okay. So like this, it should work. So let's test. Okay, so here we are, and on the client down here, let's pause, and now let's quit. And if there you go, that one automatically unpauses and everything works. Okay, great. So the pause disconnect logic is working. Now let's see basically the opposite, which is what happens if the host quits. So with the host up here and the client down there, if on the host I stop playing, and if there you go, look at that, everything shuts down, all of the players get destroyed, the network manager automatically stops running. So in terms of logic, it already works, so the game definitely stopped working. But obviously there's no visual for the players, so let's make one. Let's go inside our canvas, and over here, let's begin by duplicating the game over UI. Let's name this one the host disconnect UI. And let's put it on the sorting just before the game pause UI, so just like that, okay? Then over here, for the text, let's rename this to just say text. And inside, let's just say host has disconnected. Let's put it a little bit smaller, move it a little bit down, and we don't need these other ones. So let's get rid of these two. Just like that. And we can leave the play again button. Okay, now let's make the script to run this.
Oxi, eu não tenho esse play game button não, que você tem aí, amigo.
So with the same name, let's go ahead, create a brand new C# script for the host disconnect. UI. Over here, let's get rid of the game over UI and add the host disconnect UI, okay? Let's open. Now on this one, let's first of all add the reference to the button. So a serialized field, private button for the play again button. Okay, like this. Back in the editor, let's drag that reference, all right. So now let's make the usual show and hide function. So private void show and a private void hide.
Calma.
Just set game object, set active into false, and over here into true. Okay, we have our functions. Then for showing it, we need to know when the host has shut down. And for that, we can actually listen to the same callback. So let's make a private void start. On start, let's go into the network manager, the singleton, and let's listen to the on disconnect callback. So let's add a listener to this one. Network manager, okay. So we have this one, and again, over here we have the client ID. And now to know if the server was the one that shut down, we can basically just compare this client ID to the server ID. So let's check if this client ID equals the one on the network manager dot server client ID. This is a constant, the server server is always on an ID of 0, so let's do this. So if it is, then this means the server is shutting down. And if so, then let's show this window. And on start, let's start off hidden. Okay, that's it, a simple script. Okay, so up here is the host and the client, and if on the host I quit, and if there you go, host has disconnected. Alright, awesome. So with this, we have handled pretty much every single possible scenario. Except perhaps the more obvious one, which is enabling the player to manually quit out of the game.
Ok. Host, client. Okay.
Right now, if I'm here in the editor, let's say I start off as a host, then I go into the pause menu and go back into the main menu. Yep, here I am in the main menu. And if I look in the hierarchy, yep, the network manager, yep, it is still running. We still have an active connection. Obviously, we don't want this to happen. So let's go over here onto the Game Pause UI, and this is where we have the main menu button, so we load the main menu scene. But before we do that, let's go into the network manager, the singleton, and let's call the shutdown function. So this is going to shut down our connection. Really, we just need to do this in every place where we quit the game. So that's over here on the Game Pause UI, and the other one is over here on the Game Over UI. So we'll load the main menu, and before we do that, let's shut down the
Game Over UI. Eu não tenho esse botão aqui. Deixa eu fazer aqui então, ó. Serialize Field Private botão. Play again. Botão. E aí no meu Awake Start. Eu gosto de Awake aqui antes. Awake. Play again. Ponto. On click. Ponto. Add the listener. Pique. Ok. Eu venho aqui. Game Over UI. UI. Pá, botão. Play again. Play again. Pá. Boat. Ok, eu vou copiar esse cara, vou colocar ele no host connected. Só que nesse cara não deveria ser o play again, né? Que deveria ser o main menu. Shutdown e main menu. Eu não sei se o shutdown aqui seria necessário, né? Porque aqui o player te desconectou e tal. Mas tá bom. Deixa eu testar aqui, né? Não é isso que eu ia fazer, não. aqui. Hosted cá. Cliente. Eu tiro o host. My menu. Ah tá, é porque eu tirei a cena. Ok, mas faz sentido.
The network manager. Okay, so let's test. Here we are, let's host, and let's go back into the main menu. And yep, in the inspector we can see network manager no longer has an active connection. Alright, awesome. So here we have handled every single disconnect scenario. The players can disconnect and the server handles everything gracefully. So now that the disconnects are working, let's think about the opposite, which is what do we do to handle client rejoins? Let's talk about that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to talk a little bit about the concept of late player joins. Okay, so here's our game, which is actually pretty small. Each session of this game is only a few minutes long, so because of that, we're not going to allow late joins. Doing so adds quite a bit of complexity. So for a game like this one, we're going to make it so that everyone joins in the very beginning and they all play until the very end. If someone drops in the middle, they can simply just restart the session. But still, I want to talk about the topic of late joining because for other game genres, this is indeed extremely important. Now, the reason why handling that is so complex is due to potential problems with data desync. There are two main methods we have for synchronizing data. We have RPCs and we have network variables. The one big difference between both of them is that when a client joins late, they won't receive the current state of a network variable, but they will now receive all of the RPCs that have been sent since the very beginning of the game. In this game, we use RPCs quite a lot to synchronize tons of stuff. We use them because they are quite simple to use and very easy to understand. Like for example, setting the kitchen object parent. So let's do a quick test. Okay, so with the two builds, down here I'm going to connect the host, but I'm not going to connect the client just yet. So I'm going to start playing with the host, count the countdown timer. Now I'm going to pick up something, let's say I pick up some meat, okay? And now if I connect with the client, and now actually we have the thing where we synchronize this window, so let's manually just hide this. So I'm just going to find the window, the tutorial UI, and just hide it. And if there you go, look at that, we can now see the desync. Basically, this second player joined late, so this one knows that an object was spawned, so that object is indeed spawned, but it does not know that the first player is actually the one holding the object. So we have a data desync. The second client did not receive which one is the kitchen object parent for this game object. Again, this is the difference between spawned objects and RPCs. The kitchen object itself, that one was indeed synchronized, but for the parent data, that one is only synchronized through an RPC, so the second player doesn't know what happened there. And now if over here on this one, if I just drop it somewhere, there you go, now everything is indeed synchronized because this one is now connected, so this one now receives the new RPC. So in this case, it's not necessarily a big issue since it does end up sorting itself out, but another thing we have synchronized through RPCs are the recipes. So I'm going to start again, on this one down here, I'm going to connect as the host and start playing. And there you go, this one is now going to generate some recipes, and yep, there you go, generate one. So now on this one, connect on the client. Let me hide that UI. And if you look in there, nope, it did not receive the very first recipe. So now they have different amounts of recipes. Again, that is because we used an RPC in order to send the new recipe spawned. So this one joined late, so it missed the spawning of the very first recipe. So now the two clients have different data for what recipes are waiting. Also same thing over here on the plates counter. Again, this one is using an RPC, so you can see over there the plates counter is full, but that one missed the message spawning the first plate. So this is the main tricky thing. If you want to make a game where you want to allow late joining, then you need to design your game in such a way that all of the important data is synchronized in a way that is automatically synced. One option, like I said, is using network variables. Those are synchronized automatically when someone new joins. So even though this second player, this one joined late, you can see over there the actual timer for the game. That one is being synchronized correctly, even though this one joined late. That is because that one is using a network variable. So if you made the waiting recipe list a network variable, it would synchronize correctly. However, the reason why I use RPCs is because we cannot directly put a scriptable object inside a network variable. So over here on the delivery manager, it would require a different code in order to synchronize this list. You could either make a network variable with a list of hints to hold the index for each recipe SO, or you could implement the iNetwork serializable to teach NGO how to serialize this specific scriptable object. I covered that in the netcode video. So it's definitely possible, it just requires a different approach. Another option would be to keep using RPCs just like we're doing here, but when a new player joins, you would have the server send that player all the data they need to synchronize. So for example, over here on Delivery Manager, you could add a callback listener when a client connects. You can listen to that through the network manager, the singleton, and here is the client connect callback. So you could listen to this on the server. Then when this happens, you could have the server send a client RPC just to that client to tell them all the recipes that have already been spawned. Then from that point on, everything would already be synced. So adding support for late joiners adds a bit of complexity, but it is certainly doable. As to whether you need it or not, really depends on the game you're making. If it's a quick session game like the one that we have here, then I think it's not really worth it to add that extra complexity. But if you have a game with longer sessions, then of course that one is a must. So keep that in mind when building your game from the very beginning and deciding whether to use RPCs or network variables. So here for this game, let's not allow late joiners. And how we do that is actually very simple. If we look over here on the network manager game object, if we scroll down here there's a toggle for connection approval. Right now, every client that connects gets automatically accepted. We don't want that. So let's instead enable this. And then let's go here onto the kitchen game multiplayer script. And on this one, we can listen to a callback. However, one very important thing is we need to listen to the callback before we call the start host. So let's make a start host function over here on this class. Let's make a public void start host. And then we're going to have a public void start client. And over here we have the testing netcode UI. So these are the two testing buttons that we're using. Instead of directly going to the network manager and calling it, let's go into the kitchen game multiplayer, the instance, and use that function. So the start host and then the start client. Okay, so we go through those functions. Then over here on these, let's do the same thing. So network manager, the singleton, start the client, and on this one, network manager, singleton, and start the host. And now here, before we start the host, let's go into the network manager, the singleton, and let's listen to the connection approval callback. Let's set a listener to this delegate. Now this isn't an event, so Visual Studio isn't going to automatically run this. So let's call this network manager connection approval callback. And now let's use the Visual Studio automatic things to generate this method. Okay, so here it is. So we take an argument for the connection approval request and then another one. This one is for the connection approval response. And now here how we either approve or disapprove of a connection is very simple. We just go inside the connection approval response, and over there's something called approve. That is a boolean, so we can set it to true to allow or false to not allow. So for right now, let's make sure we only approve connections when we are in the waiting to start state. So over here on the Kitchen Game Manager, let's just expose the waiting to start state. So let's go down here where we have a whole bunch of functions. So let's go a public bool. Is waiting to start, and just return if the state.value equals the state.waiting to start. Okay, so then over here let's check. So check if the Kitchen Game Manager instance is waiting to start. If so, then we are going to approve the connection, and if not, we are going to disapprove the connection. Now actually in a bit we're going to refactor this to make it so that the connection is actually established in the lobby, but for now this testing code should work, so let's try it. Okay, so over here first let's create a host, alright, and now this one let's join right away, alright, so both of them are on waiting to start. So if I click on client, this one is going to connect, but instead of that, let's start this one. Okay, waiting for players, this one start, and yep, there you go, it starts the countdown. And actually here we see one thing that I forgot. You can see that the players weren't automatically spawned. That is because when you enable this connection approval, you need to manually tell it to create a player object. So over here when we approve, we also need to go into the response, and over here set create player object into true. So this will now revert the same behavior we had previously, where the player object will be spawned automatically. Okay, so let's try again. Over here, create the host. Over here, join as the client. All right. Now let's start this one, waiting for players. This one start, and there you go. The game has started. These two players are connected. So now it shouldn't be accepting any more players. So down here, if I try to join, and oh, there you go, it does not work. The host is disconnected. So that one can no longer join our clients. All right, awesome. Okay, so here we talked about whether you want to allow late joining or not, and the various challenges that come with adding that feature. And we also limited how the players can join our game. With that, our entire game logic is now working in multiplayer. What's left is really handling all of the other scenes. But before we build those scenes, let's actually set up the entire connection flow. So let's do that in the next lecture. Hey again, here's another quick intermission. Good job on sticking with the course. By now, I really hope you've already learned a ton from the course. Almost all of the core multiplayer logic is already done by now. Although the following lectures are also actually some of the more important ones, handling the connection scene flow, the character select scene, lobby, relay, and so on. They can be a bit tricky, so definitely do take your time. I hope you've been following the website as you go through the lectures, and I hope reading the frequently asked questions has helped you in some way. If you enjoy my teaching style, then check out my other course after finishing this one, especially the turn-based strategy course. That one would be an excellent follow-up to this one. Alright, let's go to the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to handle the connection scene flow. Meaning we're going to handle the changing of scenes and set up where we're going to actually create the netcode connection in order to prepare for the future lobby and character select scenes. We're going to start from the main menu with no connection, then the lobby scene handles the lobby list. As soon as the player joins the lobby, it automatically creates the netcode connection and goes into the character select scene. On that scene, the player will then select the character and set as ready. When all players are ready, the game will load the final game scene and start the game. Okay, so let's handle the connection scene flow. Let's begin by making the scenes. So let's go into our scenes folder and let's create a brand new scene. Let's name this one the lobby scene. And let's duplicate this one to make the character select scene. Okay, now let's first go inside the lobby scene. And over here, let's create a brand new canvas. And let's set it up as usual. So screen space overlay, then over here scale with screen size, reference resolution of 1920 by 1080, and match with the height. So the usual setup. Now inside the canvas, let's create an empty game object, call it the testing lobby UI. Let's put the width and height both on 0. Again, for this lecture, we really just want to handle the connection flow. So we're just going to make some testing buttons. We're going to set up the proper lobby in a later lecture. Inside this game object, let's create a simple button. Call this the create game button. Inside, let's put create game on the text. Let's put it a bit in bold, a bit bigger. And on the button itself, also a bit bigger. Okay, great. Then let's make another button. So duplicate this one, put it down. This one is going to be the join game button. And inside for the text, for this one, join game. Okay, we have our buttons. Now let's make a script to run this. So let's go into our scripts folder inside the UI. Let's create a brand new C# script with the same name, so testing lobby UI. Let's wait for it to compile. And over here, let's add the testing lobby UI. Okay, great. Let's open. Now this one, first of all, let's add some references for the buttons. So a serialized field, private of type button. First we have the create game button, and then we have the join game button. So you have these two. Here in the editor, let's drag the references. So the create game button and the join game button. All right. Now over here, let's do pretty much exactly what we were doing on the testing UI on the game scene, meaning we're just going to start either a host or a client. So let's do a private void awake. Let's go into the create game button, the onClick. Let's add a click listener. On this one, we go into the kitchen game multiplayer, the instance, and call start host. And then for the other one, for the join game button, on this one, we start as a client. Okay, so we have these, and this is going to start a host or a client, which also means we need to create a network manager in the lobby scene and not on the game scene. So let's save this scene and let's go inside the game scene. Then over here, let's find the network manager. Okay, great. So let's copy this. So Control C. Let's go back into the lobby scene. Over here, Control V. Okay, we have the network manager. Let's go back into the game scene. And over here, let's make sure to delete the network manager. Remember that the network manager works as a singleton that does not get destroyed on scene changes. So we need to make sure we only spawn it once. And we're going to do that just over here on the lobby scene. Okay, great. Also for the settings, we're not going to want to spawn the player right away since there's no player object over here on the lobby. So let's click to select the player prefab field and then press on delete in order to clear it. Okay, great. So just like this, we should have this button which creates a host and this one which joins as a client. But if we test right now, nothing will actually happen since we just have a connection being established and nothing else. According to our connection flow, once we connect, we want to load the character select scene, so let's do that. Over here on the create game button, we first start the host, and then afterwards we're going to load the next scene. So we go into loader, call load, and let's pass in the next scene. So let's actually add them to the list. So over here on the loader script, let's set our two scenes, so the lobby scene, and then we have the character select scene. Again, here make perfectly sure the names perfectly match the actual scene names, so be very sure the names are perfect. And over here, we're going to load the character select scene. Okay, like this. However, this part is actually extremely important. For loading the scenes, we're actually going to use the network manager itself to handle scene management. That way, all of the clients are going to be synchronized automatically. So in order to do that, we need two things. First one is over here on the editor, on the network manager. Let's scroll down, and over here we do see enable scene management. So let's make sure this one is enabled. This makes it so that when you change scenes in the server, all of the clients will automatically load that scene as well. And the second important thing is that we need to load through a different method. So over here on this load function, we are going through the regular scene manager and calling load scene. In order to make it work with the network manager, we need to do it through a different function. If you don't do it, if you just use this function, then the objects on the new scene will not automatically spawn. Personally, I found this out the hard way while making the prototype. I had no idea why the objects on the game scene weren't being spawned, and that is because I was using the scene manager, instead of going through the network manager. So if you have issues where you're changing the scene and the objects are not spawning on the network, double check to make sure you're changing scenes using the scene network manager. So over here, let's make a function to do exactly that. Let's make a public static void, call it load network, and we're going to receive the same scene for the target scene. And over here, instead of going through the scene manager, let's go through the network manager the singleton, let's access the scene manager, and in there we can now call load scene, and let's pass in the same scene, so the target scene, and as usual this one takes a string, so let's do a toString. And then for the load scene mode, you can load as additive, but in this game, in this simple game, we're always using just single, so let's go with single. Okay, so that's it, so we need to make sure we always use this function and not this function. Now, one note here, note how with this, we're actually bypassing the loading scene that we made in the single player version. I'm doing that just because handling that would be quite a bit complex, and this connection flow lecture is already a bit too long. Basically, we would need to wait until all of the clients load the loading scene before the server starts loading the final scene. So it's definitely doable, just requires a bit more complexity. Here to keep things simple, let's leave it just like this in multiplayer. So it's going to load the scene right away. So back here in our testing lobby UI, instead of using the load, let's use the load network. And also over here on the client, on this one we do not need to add it, because the client will automatically load to match the scene that is loaded on the server. Okay, so with this we're almost ready to test. We just need two more things. First of all, over here when calling start host or start client, in the end we're going through the network manager, but right now we're actually going through the kitchen game multiplayer. So we also need this object on the lobby scene, just like we have the network manager. So let's save the lobby scene, let's go inside the game scene, let's find over here the kitchen game multiplayer, let's copy this back in the lobby scene, paste it, and back in the game scene, save the changes, and clean it up from here. Okay, great. So we have it just over here on the lobby scene. However, we have another sneaky issue. Like this object won't be destroyed when we load the character select scene. We don't want that. We want this object to persist for as long as the network connection is active, pretty much just like the network manager. So over here on the kitchen game multiplayer, on the awake, we can simply do don't destroy on load and pass in this game object. That will make sure that this game object does not get destroyed when the scene loads. Okay, great. So one more thing, it's over here on the connection approval callback. In the lobby, we don't have any waiting to start state. So for now, let's just always accept the connection, and then in a little bit we'll handle the proper logic. So just set this one as approved as true, and let's get rid of the rest. Okay, we're almost done. Just one final thing, which is let's go into File, into the build settings, and over here in the build list we need to make sure to add our new scenes. So let's go ahead, find the lobby scene, drag it, and the character select scene, drag it. And also for testing, we're going to need to make sure to start from the lobby scene, so let's just drag it over to the top, so that one is on index 0. Okay, so we can now test. So let's make a regular build. And over here in the editor, make sure you are on the lobby scene when you hit on play. Okay, so here is the editor and the build both running, both working great, so there are no errors. If you have some errors in your game, go check the error. Chances are you possibly forgot to copy one of the objects onto this scene. So with this, everything is already working correctly. And now on this one, I can press the button to create a game. And if there you go, it goes into the character select scene. And then on the build down here, I'm going to join the game. And if there you go, it also loads that scene. Alright, awesome. So the first part is working. We're going from the lobby scene to the character select scene with no errors. Now let's handle the transition from character select onto the game scene. Let's go into the character select scene. And over here, as usual, let's make the canvas and set it up. So a brand new canvas, screen space overlay, scale with screen size, with 1920 by 1080, and let's match fully with the height. Okay, great. Now inside, let's create an empty game object for the testing character select UI. Inside it, let's create a new UI, create a new button, call this the ready button. Inside, make it say ready. Okay, we have the button. Now let's make a script to run this. So let's go into our UI folder and create a new C# script. Let's add the script, so the testing character select UI. Okay, let's open. Over here, let's begin by adding a reference to our button. So a serialized field, private button for the ready button. Okay, let's save. Back here in the editor, let's drag the reference, all right. And now the goal here is to pretty much use exactly the same logic that we made for the kitchen manager. Over here on the main game manager script, we had the ready logic, so the game would only start when all of the players were ready. So the logic is exactly the same. So let's actually copy the exact code. So let's copy first of all the play ready dictionary. Except we don't want to run that logic directly over here on the UI script, so let's make a proper script. Let's create a brand new game object for the character select ready. And let's make a script with the exact same name, so the character select ready. Let's reset the transform and add the character select ready, okay? Now this one, let's actually paste that code. So first of all, let's copy over here the play ready dictionary. And over here, let's paste it, okay? We have the dictionary. Then need to initialize it on awake. So on awake, the play ready dictionary, let's make a brand new one. Then let's see what other logic we're using with this one. And it's down here, we have an RPC in order to set it as ready. So let's just copy this entire function. And over here, let's paste it. And when you do, make sure you add using Unity.NET code up here. Visual Studio should do it by default, but make sure you do it. Okay, so this is really going to do the exact same thing, so go through the player ready dictionary and see if they are all ready, and if so, then it's over here. Instead of setting the state, over here we're just going to load the final scene. So going to the loader, and again remember to use the load network function, and we're going to load the game scene. Okay, so that's really it, super simple. Then for calling the server RPC, let's expose a function, set play ready, and over here we call the set play ready with the server RPC. So we just need to call this function from that button in the UI. So let's go